Welcome. I'm Dr. Patrick Brunese, and I'll be joined by Elizabeth Pearson, and we're presenting industrial engineering, or what we're going to call industrial engineering, your major. So we want to start in a sense about what do industrial engineers do. Most people don't have a great concept for what makes up industrial engineering, and we're only going to get to present a small piece of it, but something that hopefully covers the breadth of the types of problems that we like to solve, or the way that we like to solve them, and how we fit into the broader scope of industry and other areas where you'd be able to apply the skill set that you get as an industrial engineering graduate. So I'm going to start and present an example back to essentially, or hearkening back to essentially, the origins of the field of industrial engineering. So we got our start in manufacturing. And we still do a lot of manufacturing. If you think about it, how much in your life really isn't manufactured? It's going to take you a while to come up with some really good examples there. And I'm going to use automotive manufacturing because a lot of people think about industrial engineering in the context of mass production and other types of very large-scale manufacturing systems. And so I'm using a more modern version of it, but industrial engineering really evolved out of the need to make things faster, more efficient, better, etc. And so I'm going to use automotive just for the sake of our picture here that we're going to build on. So just take a second to look at this photo and think about all of the stuff that's going on. I'm going to break it down into 4 essential pieces that make up the core of how we think as industrial engineers. First thing is essentially what happens at the material level. So all of the components of those vehicles that you see in this picture are made up of a set of materials. There's plastics, there's metal, there's composites, there's all kinds of different materials there. And they get transformed from their material state, or a part of their material state, all the way through to whatever the component part is that happens to be on that vehicle. So we're concerned with materials. We're also concerned with the transformation of how those materials become something useful. So we need to ask the question, what is the best material that we could potentially select in order to be able to say that we're making the best selection for the particular good that we're going to manufacture in this case. And in this case, it would be the component for these SUVs. In order to be able to do that transformation process, we have to work with technology. We have to, it could be machined, it could be a part, where we're removing material from sort of a bulk mass, or it could be built from the ground up with additive printing, essentially 3D printing or additive manufacturing. There's lots of different technologies available to do that transformation process. So now we've got materials and we've got the technology that's available, and we're going to ask a similar type of question. What is the best way to get from material to the final component, considering the options that we have in order to do that production? We also need to be concerned with the usage of that piece of technology over its lifetime. I'm going to elaborate on this a little bit as we go forward, but the idea is that we're not just designing a system for this moment to produce one item. We're maybe talking about systems to produce tens of millions of items or hundreds of millions of items. It could also be 1 or 2. So we have lots of different scope for the usage of the technology, the materials that we're going to use, etc. We have to operate this technology. We have to be able to make the system work. And a large part of making any system work is the people that are a part of that system. So we have operators, we have engineers, we have technologists, we have all kinds of different functions that people serve in this transformation process, from getting from materials to usable components, from usable components into the assemblies that you would see to getting to a final vehicle. So people are also a major source of the systems, or a major part of the systems that we design. So we've got to be able to design their working space effectively so that the work that they do can be done safely, it can be done efficiently, and it can be done effectively. And as we operate a system, we're concerned with how well that system works. So data, information, whatever term you want to use, or at what point you want to think about the conversion from data information, is also at the center of all of this. Because nothing that we interface with, the types of materials that we use, the types of technology that we use, the people that we work with, work exactly the same way every single time that we perform any one of the tasks that would have been associated, let's say, with making the cars that are now in the backdrop of here. So we're concerned with the materials, the technology, the people, and data and information. Another way of thinking about it is that we're concerned with these transformation processes. As we do things in this system, we're concerned with how material becomes parts, how parts become part of a larger whole. We're concerned with how people fit and operate within the system. We're concerned with how the system works as a whole. So we're concerned with lots of different forms of transformation. And so industrial engineers integrate, and I'm going to provide another term for this a little bit, but we integrate, so people with technology, materials, and information and data. And so we always have the question is, as engineers, we're always going to design something, or we're always going to interface with the designs of things. And we need to know, is it doing what we said it's supposed to do? Or is it doing it over a long, whatever the period of time is appropriate for the system that we're talking about? So we're looking at the now, we're looking at the immediate future, we're looking at the long-term future, we're looking at a lot of different types of components when we think about the design and an operation of the systems that we work in. I'm going to expand it out a little bit. The picture is going to get a little less descriptive. But if you think about it, this extends from the point where we receive these materials all the way to the point where we interface with the customer and potentially back again. And so we have suppliers that we need to work with. We have the plants where we actually do the production. We might have assembly plants if we do the component production and the assembly work in a different place, which is actually typical of an automotive environment. We have distribution centers or warehouses where we store components until they're ready to be delivered to the customers. And then we have the customer locations and so forth. And so we really think about the design and operation of these systems from the point where they originate all the way through to where they interface with customers and beyond. So we would often call this a supply chain or a logistics system. So if you hear these terms, then you're probably thinking very much in some, along the lines of areas where industrial engineers have a large impact. So I want to elaborate on another piece just for the sake of thinking about additional problems that IEs would care about is, what suppliers are we going to use? So not just what materials, but who provides the materials to us as we're going to build the system and operate the system over time. It's a major question. Working, selecting suppliers, managing relationships with suppliers, et cetera, all requires a lot of design activity and management activity. We're concerned with where we put all of this in space. So where do we do production? Do we do production somewhere globally? Do we do production more locally? Do we do production in a single plant, many plants, et cetera? Where do we put it in space, so to speak, is a major question and has a large impact on how well we can operate the system over time, because we're considering how hard it is to get materials or the complexity associated with getting materials into the facility so that we can do the tasks to make the item that we're going to make to sell. And then again, how do we get it out so that we can actually deliver it efficiently to customers? Where do we put the warehouses? Again, if we're going to ask where do we put the production, we're also going to ask where do we put things like distribution centers and warehouses. And then what do you put in any one of those places in order to meet the demand of customers? I'm going to shift gears a little bit and think about if we put data, materials, technology, and people together, there's really no limit to the types of systems that we could actually develop. I was talking about supply chains or logistics systems before. We were talking about manufacturing environments, but you can actually design experiences in much the same way. And so if you think about, I'll ask the question of you just for yourself. Have you been to Disney or a Disney property or another theme park and noticed the way that people move around in the space, noticed the way that they manage lines, that they manage the activities, et cetera? If you've noticed any of that, and thought about how the process worked for you, you've probably been interfacing with industrial engineering. The experience of the park is largely designed with the same concepts in mind, by industrial engineers in order to make sure that your focus is on the actual experiential activity that you're planning and not the actual completing the task, so to speak, of getting in line, getting out of line, getting on a ride, getting off of a ride, getting to the next activity, et cetera. So these things can be, integrated in these 4 things can be integrated in many different ways. And so they might ask, how do we improve the wait experience? And so there's a portion of that that is very much a physical designs concept, and there's a portion of it that's very much based in psychology. And so industrial engineers, because we're talking about the interfaces with people and technology and so forth, are able to design these in such a way that hopefully you have a magical experience. So I'm going to pull this back around. What is industrial engineering? Our name is not particularly descriptive, at least in the way that you might think about the other engineering majors. And we work very closely, as you might imagine, with every other engineering major that's out there, because a lot of the other engineering majors are concerned with the design of those pieces of technology that we would use in our systems, the design and usage of materials that would be, again, used as components or transformed into components. Or let's say, the components of an information system, et cetera, that we would use to process data and generate the work that we, or the types of analyses that we would do. An easier way to think about industrial engineering is that we exist in every industry. And so part of industrial engineering is the concept of designing elements of industry, which are, another way of thinking about it is as a human integrated system. So a manufacturing system is a human integrated system. A warehouse is a human integrated system. The overarching organizational unit that might control a supply chain, or that might control production, or that might operate human resources even, is still a human integrated system working with different forms or definitions of what is material, what is the transformation process, who are the people, what are the data and information that we can use to operate that effectively over time. So industrial engineers design, analyze, improve, manage, control, many different terms that you can use there, human integrated systems. And human integrated systems are a part of every industry that is out there. So when you think about industrial engineering, that's what I hope you'll be left with. And so now take a look at some of the terms that are associated. So I've hit on some of these terms in the course of this presentation, but here's a neat graphic that was developed by another IE program that we're closely related to. And you'll see things like the design of a facility has a lot of components that are important to the effective operation. So if you thought about that initial picture again, where all of those pieces of technology exist in space is part of facility planning and design. The work design, how do you actually design the work for a person in that space? So that if you go back and again look at that picture, or think about that picture, you saw operators installing, I think it was the back glass in that car. How do they do that effectively so that they don't injure themselves? And so they do it within the right amount of time to be able to make enough cars to meet demand. That's part of work design and measurement. And so if you go around, you can see several different variations. Some of the other terms might not be as familiar, things like analytics and operations research, or how do we collect and use data to be able to make decisions that would allow us to be able to continually operate the system in an effective and an efficient way. And so often you will not find people termed industrial engineers in industry. What you'll often hear somebody referred to as a data scientist, or a data analytics professional, or an operations researcher, or an ergonomist, or a facility designer, or a manufacturing engineer, or a process improvement engineer, or an operations analyst. There are many, many, many different terms for the roles and responsibilities that IEs take as they go out into industry in the various areas that they might work in an organization. And so it makes sense to then also think about where IEs would go. And if I'm saying that IEs exist in every industry, you'll note that the breadth of companies that might come and hire our students, and this is a set of examples of recent employers. It's not a complete set, but it's pretty representative of where our students go. And you'll see technology companies. You'll see consumer packaged goods. You'll see healthcare companies. You'll see food and beverage. You'll see pharmaceuticals, automotive, experience, and consulting. And essentially, where our students go is in lots of different roles and responsibilities in these organizations as well. And so these are some of the jobs that our students have taken from some of the companies that are listed on that previous slide. Once again, as I talked about, the depth and breadth of being able to design and analyze, improve, and control human integrated systems exists everywhere. So you'll see something like a compensation analyst in Lilly would be somebody who would actually work in human resources, and even HR director. You'll also see, like I said, data scientist or operations roles. And so they're concerned with, the understanding of the information that they can collect from the systems that they develop, and then how well those operations work for whatever they might be doing. And so at PepsiCo, that might be production of soda, or if it was on the Frito-Lay side, it could be production of snack chips, et cetera. And so you'll see several examples across a broad array of positions in each one of these types of companies. And you'll see these from entry-level jobs to very senior management type roles like vice presidents or senior vice presidents. It's very common for an industrial engineer, because of this type of training, to end up in senior leadership in the organizations because of the ability to address problems that are complex, that involve the mixture of people with materials, technology, and data. And it does make sense as well to talk about where things are going. So you've probably heard about, you probably are interested in some way, shape, or form, the advancement of automation and robotics, things of that nature. How humans work with and around technology is of critical importance. And so building in effectively designed automation systems or automated components into an existing system is a really growing area in industrial engineering, and our ability to assess how things work in space and time and with people puts us in the forefront of the ability to do this. You'll also see a lot around environmental sustainability, circular economy, and supply chains, because the ability to operate under many different forms of material requirements or emerging needs from an environmental standpoint requires very different types of variables that you control for in the design of the system. The ability to say what happens after a customer uses it, how does it get brought back so that you can reuse and recycle materials is a major question. And then how do you do this in such a way that the material travels through the system in really effective ways that also allows for efficient transportation, the right material at the right place at the right time, et cetera. These things are all linked together. And so obviously supply chains are big as well, and these actually all fit together. In addition, just the ability to collect, analyze, and use data at all scales. So industrial engineers are capable of working with really simple systems that don't generate a lot of data, or all the way through systems that generate massive amounts of data, and be able to synthesize that, make decisions around it based on whatever the needs of that decision-making process may require. So you could end up with sales data in thousands, hundred thousands, millions of units, or customer interaction data as another example, all the way down to very small scale, high precision, let's say manufacturing, and looking at the actual material properties imparted through the process. You might only make a handful of those components, but be able to understand the quality, the ability to use that as the component part or finished good as intended are major concerns. And so the ability to put sensors in the right place, to be able to collect the right data, process the right data, generate insights, and make decisions is an evolving area. And you might hear the terms big data or Internet of Things, artificial intelligence, machine learning. These are all areas where IEs actually have been trained in variations of these topics for many, many years, but is evolving along with the general evolution of these tools and techniques and approaches. And so we're sort of at the forefront of where industry has been, where it is, and where it is going. And it's just changing the nature of what exists as a material, what exists as available transformation processes, what exists in terms of the interfaces with people and the types of types, structures, and usages of the different data and information that we can collect. And so our education reflects, at Purdue, reflects this breadth. So once again, human integrated systems everywhere in industry, the ability to train engineers to be able to meet the needs of companies across the entire world is what we believe we are capable of here, and we've designed, tried to create, develop, maintain, and expand opportunities for students on that front. So at this point, I'm going to bring up my lead academic advisor, Elizabeth Pearson, and she's going to talk more about, more of the experience of industrial engineering at Purdue.
Thank you, Pat. Hi, everyone. I'm Elizabeth Pearson. I'm the lead academic advisor with industrial engineering here at Purdue, and I'm going to talk a little bit about what your experience as a student would be like if you were to select industrial engineering. So let's start with courses. Everybody always wants to know, what am I going to be taking? What's my life going to look like each semester and everything? And so here at Purdue, we have a holistic industrial engineering curriculum. Some programs at different universities may focus in one of the main 4 areas of industrial engineering, but here at Purdue, we cover a solid basis of all 4 of them, and then our students are able to use their electives to really dive deeper into a specific area if they have that interest there, or continue with the breadth of staying a little more broad and less deep. It's really up to them. But the 4 areas of industrial engineering that we cover: human factors and systems, production systems, manufacturing, decision-making, and operations research. Those are kind of the 4 core pillars for industrial engineering, and you can see there we have classes in each and every one of them. Most of these areas, we have 2 classes that students take, one kind of introductory level and then a higher order class where you're maybe involved with more of a case study or a project. It just kind of depends on the structure of each class. Now, supporting courses, all of our students take probability and statistics, a couple courses in there just for that data foundation. We take a computing class where you cover a large breadth of different coding systems, databases, and all of that technical information so that you can go into any circumstance and problem and know how to tackle it and what avenue to best attack that. We cover engineering economics. A lot of industrial engineering problems kind of boil down to money and, what's the cost, what's the benefits, and everything. And so we have that. That's a favorite course for a lot of our students. And then what I think is a really great additive for our program is our senior design project. It is always an industry-based senior design project. You're not coming up with something on your own. It's not hypothetical. We have industry partners that we get real problems that they have at their companies they need solving and they don't have the bandwidth to solve it, or they're looking for an IE perspective or any other circumstance. And so our students come and they have usually groups of 5 to 7. They work on the problem for the semester, they present to the company, they write up a report, and sometimes, very often, the projects and the solutions are implemented, at least in some portion, within the company. So it's a really cool experience for our students to just kind of cap off their experience here at Purdue. Other opportunities within IE to kind of make your time here your own. We have a lot of students that have a minor of some kind. Management and economics are certainly some favorites. A lot of our students say, I like engineering, but I also really interested in business. And so I was kind of between the two. And so management or econ minors are very common to see, but also statistics, math, different certificates like an entrepreneurship certificate or a systems certificate or the data science certificate are also really common for IEs to take. They tend to have a lot of different interests, and so with the flexibility of our curriculum, we can use your electives in order to kind of make those goals happen. You just have to talk with your advisor and we can find a path for you. We talked about the 4 core areas of industrial engineering, but some of those emerging areas that Doc B talked about were like healthcare engineering or data science and analytics. We have higher order classes that are really diving into those things in more detail, and you can use those for electives as well. We also have undergraduate research opportunities. So some of our faculty, they're working in these really kind of outlier, cutting edge kind of areas within industrial engineering and collaborating with other areas. And so you have the opportunity as a student here in industrial engineering to work on an undergraduate research project with one of those faculty if you so choose. We also have a lot of co-op students. Some do the professional practice 3 and 5 sessions, but many just decide, hey, I want to take a co-op, like I'm accelerated or I don't mind delaying graduation for like a semester or something, and they do an 8-month internship or kind of break it up and maybe do a couple of different things. So lots of different opportunities in terms of getting that external job experience, professional development within the school. And we also have a lot of gear and study abroad students, and I'll talk about study abroad in a minute here. So study abroad at Purdue, you may be familiar with and have heard these LEAP and STEP programs. So LEAP are the longer term ones. So those are what we think of semester exchange. And we've had numerous partners in many locations around the world. We've sent people to a lot more places than just what's listed here. But these are some of our most common partners when it comes to semester exchange for our students. So going to China or Colombia or Italy, Sweden, Hong Kong, Singapore, Australia, we've had some of those as well, or Spain is really popular. And so we really encourage students to go abroad if that's something that you're interested in. And we say, if we can get you classes, we will send you there. We don't require that you have to take core courses or anything. We just work with your advisor and we make a plan, and then we can hopefully execute the plan. If a long-term kind of semester exchange is a little much for you, or you just want to do more and you only have so many semesters, we do have some summer programs that are within IE, and then our students do take advantage of a lot of the other ones that are available through Purdue study abroad programs. So we have several IE-led summer programs that are basically, they're both Maymesters. And so we have the systems dynamics modeling for engineers that goes to Pamplona, Spain for about 3 weeks. So you live, you work, you don't work, you live and you study and get to do some cultural visits and components as well. And then we also have a TVS India internship, and that is a class and an internship. So also a Maymester, several weeks in Bangalore, India, where you work on a project for TVS India, and then also take a class with Doc B and some of the Daniel School of Business faculty. But like I said, there's many other STEP and LEAP programs and global engineering programs that our students take advantage of. Oftentimes we can use them for technical electives or general electives. There's a lot of programs out there, and general electives are really flexible. There's just so many options. And so again, just talking with your advisor, saying, hey, this is something I'm really curious about. You can talk with them, and then they can help you work your specific plan in your circumstance and understand what's available to you. So for our students, so outside the classroom, we have a lot of leadership and professional development opportunities for our students. We have numerous IE-specific or IE-concentrated student organizations. And so, for example, the Institute of Industrial and Systems Engineers we have one of the largest student chapters in the country. So, and it's very active. I believe there's over like 250 students that are involved with the Institute for Industrial and Systems Engineers, or IISE. They put on our career fairs that we have in the fall and the spring. They do a lot of professional development. They host some certifications. It's a really great opportunity for students to get involved with IE in the school, develop themselves, and have some fun. They put on a lot of different programs. We have a couple others here. There's some that are very specific, like the Human Factors and Ergonomics Society, or INFORMS. Those are very IE specific to those specific concentration areas that students may have interest in. And then Purdue Solutions and Purdue Think, along with many of the other consulting clubs that are on campus, our students get really involved with. Purdue Solutions and Purdue Think were both started by industrial engineering students, so that's why we highlight those. But our students get involved with all of the consulting clubs. They really enjoy that. And then the one in the center is very obscure and you don't really know what it is, but that is Alpha Pi Mu, which is our Honor Society for Industrial Engineering. really great opportunity for students that are invited after their sophomore year. They're invited to be part of that society. And then again, just professional development, some research components, and it's a really opportunity to just grow. And so other student experiences that we've had over the years, we have a lot of students that are interested in startups and entrepreneurial minded. And so Froyo Express isn't on campus anymore, but that was a student startup that we had here. EMU Backpack was another student startup. That's got a massager in the backpack, so that was really, really cool. And then some student consulting things. Algo Wealth is a financial kind of management and algorithms company. And so we have some student startups. A couple of these were used for senior design projects as well. So if you do have I mentioned you don't have to come up with an idea, but if you do have an idea that you want to use for senior design, we can have a conversation and we can see if that's something that would fit the scope and the needs for senior design to meet that. So we have a lot of opportunities. We'll hear a lot if you come to IE, let's have a conversation, because we want to try and make sure that your experience is what you want it to be. And so we know what's possible, and then we can kind of see what we can do to make your dreams come true. I mentioned career fairs. So we do have 2 IE specific career fairs, one in the fall and one in the spring each academic year. In 2023, we had, you can see 85 companies total between the fall and the spring that came to recruit just industrial engineering students. At IR, Industrial Roundtable, we had 267 companies that were looking to recruit industrial engineers. Expo, I don't have the numbers for that right now, but also very highly recruited there. And then over in the Daniel School of Business, those career fairs are often open to industrial engineers as well, because any operations jobs, supply chain jobs, data analytics jobs, a lot of those are going to be looking for industrial engineers as well, in addition to like the Daniels majors. So our students get recruited there too. We have a lot of alumni engagement that is kind of incorporated into our student experience in IE. So in our sophomore seminar course, we bring alumni speakers in and they share about their careers, life lessons, networking, about their companies. So it's just a place for networking opportunities for you just as a sophomore, like straight out the gate. You can interface with alumni that are very successful in many cases. And so it's just a great opportunity to get you moving towards your career goals. Senior design also, like I said, we do industry projects, but a lot of those industry projects are sponsored by IE alumni. They really love to bring back their companies to work with Purdue IE, and then, there's networking and jobs can come from that, and just really great opportunities for you guys. We also have a 2-way mentoring program in industrial engineering, and this is each semester we have a program that is a 1-to-1 mentoring partnership for 7 weeks, and that is 1-to-1, an alumni and a student, and you meet every other week for, you talk about life and topics and different things. We help and give some structure, but it's another great opportunity for you to connect with alumni outside of Purdue, for them to connect back to Purdue, and to help give you kind of some visualization of what is life after college, because right now it tends to get very, you're in the grind and everything, and you're in these classes, and it can be really tough. And this just gives you a little bit of light at the end of the tunnel to work towards. So we like to bring the alumni back, and they love to come back and engage with Purdue IEs. And then professional development, IISC does host some certifications once a semester. They usually do some big certifications. If you haven't heard of Six Sigma Green Belt or Lean or any of those are some kind of professional manufacturing optimization certifications that are really great for a resume. And they are offered at a prorated rate for students here on campus. And if you come to IE, you'll get more information about that as it comes. But we do kind of look for some other opportunities outside of the classroom to help you develop. And then some numbers, because y'all are engineers and you like numbers. So we're a very large and diverse program. We have 77,300 alumni right now that are working actively, and over 13,000 total. So it's a good network. There are IEs all over the place, as Doc B mentioned, any industry really. We got them all over. And so it's a great network for you to be able to tap into. We are highly ranked the #2 undergraduate program in the US, #8 graduate, and then the #1 online master's program. So it's a very rigorous program. It's a highly respected program, and we prepare you really well for industry. We have about 750 registered students. We have a lot that go on co-ops or come in and out, and so we have a good amount of students. And then you can see the other demographics there. I'm not going to read them all off, but we try and celebrate all of the different differences and have all of these different students. And we like it. We like being able to have all of these different perspectives come together, but still have the common unifying, you're an industrial engineer, you're a Purdue industrial engineer. So some fun toys that we have. So in the Lambertus and Dudley halls, we have many labs. I think 4 or 5 labs that are over in Dudley and Lambertus. The one that you may have seen already that is very well known is the Build at Scale lab. So that's the big 2-story high bay manufacturing space, 10,000 square foot space that is on the first floor with big windows. You can see it there. That is got all the toys for manufacturing in it. We've got 3D printers, we've got some robots, we've got milling machines, we've got lathes, we've got CNC machines, a whole bunch of stuff for our IEs to play with. You do get to take the opportunity to take classes in that lab. It is an instructional lab. And so just some really cool things that are coming up. And we're constantly being told about different technology that's being added into the other labs that are working with like human movement or big data and a lot of things. So it's really cool opportunities for you guys. But what's it really like? So usually at this point, we have some ambassadors that are here, like current IE students, and we ask them, it's Q&A, but since you can't really ask the Q, I'm gonna show some of the YouTube videos that is gonna kind of help us out and give you a little more perspective into the student experience.
So I'm Hallie Lynn. I'm from Houston, Texas. I am currently a junior here at Purdue studying industrial engineering, and I am minoring in psychology to kind of do a little bit more of a focus on a human factors route. So I came here for a summer program through the Honors College, and I really found that Purdue has a culture of this kind of group mentality, and so I was really looking for that, where it was everybody is working together for a common goal, and I found that really with the IE department that was just kind of the case. I knew that I wanted to come and pursue industrial engineering as I was a high schooler coming into college, and so really when I looked at the program, I looked at kind of Purdue as a whole. I knew that it was just a great fit for me from a personal standpoint. I knew that industrial engineering, it was just a mindset that I had already had. Really, I think I was just approaching life from a process mindset, and IE allows me to kind of dig deeper into that, not only kind of looking at a macroscopic, but just kind of to apply the math, to apply kind of those actual kind of, I guess, steps and those techniques to really break down a process and really look at kind of what's happening and how can we ultimately make it better. I really just loved the fact that the IE department here has us focus on so many different aspects of industrial engineering, with the field being so broad. Each class allows me to explore each individual field. So then when I graduate, I don't feel like I've kind of been narrowed into something. So I feel like I've been able to get exposed to so many industries within IE. This past spring through summer, I interned with Disney in their industrial engineering department. The first semester I worked with the resorts team, so I got to help support the opening of the new Galactic Star Cruiser resort that they have there. And so that was a really great experience. I kind of not only got to learn the business side of things, what does it really take to open up a new resort, but also to kind of apply the time studies to go through and kind of look at processes before and making sure that we were ensuring the best possible experience for the guests. In my second semester, I worked with their parks team, so I worked kind of with their security and their attractions, and also kind of with their Genie Plus expedited access team to. I built a Python model for them that was able to forecast some future utilization. And yeah, it was a great experience.
Hello, my name is Emma Conklin-Yokel. I'm a junior studying industrial engineering here at Purdue with a minor in business management, and I'm also studying here at Purdue's Honors College. Ever since I heard about Purdue's IE program, I kind of knew it was the place for me. I love that it had a unique combination of the more technical sides of engineering, the math, the physics, and the science, but also a unique array of other courses that I was able to take in areas like optimization, statistics, and economics. I feel like this unique combination really gave me a different perspective of both engineering and those business concepts, which allowed me to have kind of a unique skill set when looking into careers in the future. I knew that I could go into a wide range of areas. I could go into areas like supply chain, manufacturing, or consulting, or even go directly into business if that's something I desired. So having that wide array of options was really kind of beneficial to me, being a senior in high school and a freshman in college, not knowing exactly what career path I wanted, but I knew IE was going to give me a lot of options. So when looking for internships this past year going into my sophomore year of college, I was really helped out with all the opportunities Purdue had for me. I was able to attend both the Industrial Roundtable Career Fair, but also the Sigma Career Fair, specifically for industrial engineers. And I was able to interview with a lot of different companies. And out of those experiences, I was able to get a manufacturing internship with Procter & Gamble. So with them, I was kind of doing a lot of loss elimination projects. It was a very stereotypical manufacturing environment. So I was working hands-on in a plant with technicians and with other engineers, trying to improve processes and making very name brand products that you see on the shelves all the time. We were working on fabric care like Tide, Gain, Tide Pods, and Downy. So it was really cool to work hands-on with those brands that I'm seeing in the stores all the time, and also get a wide array of experience in not only manufacturing, but I was working on digitization, loss elimination, process improvement. And I really enjoyed that opportunity and was really happy with my whole experience. So having made that decision, I couldn't be happier. I've been met with amazing peers, amazing advisors, and just a great community that is Purdue IE. And I feel like I have seen all of those opportunities already presenting themselves to me as I move throughout my college career. And I just couldn't be happier with my choice to go Purdue IE.
Thank you. So that's industrial engineering. I'm going to put up some information for you. If you want to ever meet with an advisor, we're always happy to talk with students that are interested in IE. We have drop-in hours, and those are always available to students. But thank you for watching. We're really excited to get to talk to you, get to meet you, and help you with your time here at Purdue.